Alright guys, this is Mr. Trutna. This is Math 1 from Clovis High School. These are the solutions for Worksheet 5.3G. We're going to do numbers 1 through 22, but we're going to skip 20 and 21. Remember to smash that like button after you watch the video. Okay, let's start it off with a random thought to ponder. So if glue is sticky, why doesn't it stick to the inside of the jar and make it impossible to pour or to squeeze it out? Give a shout out to my 6th period guys, Trevor, Dylan, Isaac, Tyler. You guys are doing a great job. Keep up the good work. Okay, so here is worksheet 5.3G. Let me zoom it in just a little bit easier for everybody to see as you're watching at home. Okay, so in the first 8 problems, we're going to determine whether each table or rule represents a linear or an exponential function, and then we need to explain. So when we have a table in numbers 1 and 2 and 5 and 6, what we're doing is we are looking at the x values and we're seeing if they're increasing or decreasing. So you could see that the x values here are always increasing by 1, and then we're looking at the y values and we're seeing if they're increasing or decreasing. Okay, so you can see the y values here are increasing, and they're always increasing by an addition of 4. Okay, so whenever the y values or the x values are both increasing by an addition or a subtraction, that makes this problem linear. So number 1 is going to be linear. And the reason is because my common difference, this is what we call whenever we're increasing by 4, my common difference is going to be 4. Okay? In number 2, you can see the x values go from 1 to 2 to 3 to 4, so those are increasing by 1. But then the y values are increasing, but they're increasing not by the same amount being added, obviously, because 9 plus 27 is 36. But if I added 27 to 36, that would not be equal to 144. What I'm doing is I am multiplying by 4. So 9 times 4 is 36. 36 times 4 is 144. 144 times 4 is 576. So if you're increasing by an amount and the amount is being multiplied by the same amount each time, that's an example of an exponential function. So number 2 is going to be exponential, and the reason is, to explain it, we would say that the common ratio is 4. Okay? Ratio in math implies that we're multiplying by the same amount every time. Okay, number 3. Number 3 is going to be exponential. We have the equation y equals 2 times 5 to the x power, and the reason why that we would explain why it is exponential is because x is the exponent. So anytime you get an equation, if the x is going to be in the exponent spot, or the value or the place, then that's going to be an exponential equation. You will see in number 4 we have y equals 2 times 5x. Now if we wanted to simplify number 4, we could actually multiply these two together and make this y equals 10x. Now if you notice, there are no exponents at all. So if an equation has no exponents, then that equation would be considered linear. So it's linear, and my explanation would be no exponents. All right, number 5, once again, we're going to be looking at the x values and the y values and trying to find the amount that we're changing. So you can see the x values, we're adding 2, negative 2 plus 2 is 0, 0 plus 2 is 2, 2 plus 2 is 4, and then typically it's the change in the y values that is going to give us the clue as to whether or not a table is an exponential function or a linear function. So you can see that we are increasing okay, from 0.25 to 1, from 1 to 4, and from 4 to 16. So obviously we're not adding by the same amount. And I know that because if I would add 3 to 1 to get 4, but you can see to get from 4 to 16, I'm definitely not going to be adding 3. So because it's the amount that I'm adding is not constant, we know it's not linear, so now I want to see, am I multiplying by the same amount? Okay, so what I'm going to do is I'm going to start right here at 1. I'm going to skip 0.25. I'm going to get back to it. I'm going to say, what would I multiply 1 by to turn it into 4? I would multiply by 4. If I multiplied 4 by 4, that gives me 16. And indeed, if I multiplied 4 by 0.25, that's like a fourth, that would get me to 1. So number 5, because I'm multiplying by the same amount, we know that number 5 is going to be it's an example of an exponential function. And to explain it, I would say the common ratio is 4 over 2. Okay, so my common ratio is 4 over 2, which would be 2 there. Okay, all right, number 6. You can see my x values are increasing by 1, and then my y values are going from 37 to 44, so I'm adding 7. And then I'm going from 44 to 51, so I'm adding 7 again. And then I'm going from 51 to 58, so I'm adding 7. So the amount that I'm adding stays constant the whole time. That would make that table a linear function. So it's linear, and my explanation, I would say that the common difference is 7 in this case. Okay, it's actually 7 over 1 because it's my change in my y values, 7 over my change in my x values, which is 1. So really my common difference is 7 over 1, which is just 7 for my common difference. Okay, all right, number 7, you can see we have the equation y is equal to 6 times x, or 6x minus 7. Because there are no exponents at all, this makes this a linear function. Okay, it's linear, and to explain it, there are no exponents. Moving on to number 8, you notice we have an exponent, and the exponent is itself x. So this would be an example of an exponential function. Anytime you have x as the exponent, x is the exponent, that makes the function an exponential function. Okay? All right, in numbers 9 through 12, now we're going to move down and we have word problems, and we are trying to determine, can you model the situation by a linear function or an exponential function? Okay, and then we're going to explain. So Kyoko's score increased by 10 points each time she played a video game. So in this problem, if you notice, we are increasing, and we're increasing by 10 points each time. So if the amount that you're increasing by stays constant, it's never going to change, Kyoko's score will always go up or increase by 10 points every time. That means that is a linear function. Okay? And to explain why it is a linear function, we would say the increased amount is constant. Increased amount is constant. That's how we know that something is a linear function. So you look at number 2, it says the value of Drew's car decreases by 6% each year. Okay? So in this problem, the car is decreasing, and it's decreasing by 6%. Now, what that means is that the value of his car won't go down by the same amount every time. It go down by the same percentage, but the value won't go down by the same amount. So anytime you see the symbol percent in a problem, that's going to be a clue that your function is going to be an exponential function. Okay? And to explain why that is, you would just write something like decreasing by 6%, which is a different amount each year. Okay? Different amount each year. Okay, number 11. The population of a pack of wolves has been increasing annually by 1/8. So we know that we're talking about population. We know that it's increasing, and it's increasing by 1/8, okay, of whatever the population is. So that means that it's going up, and it's going up by 1/8. Now, it's going to be 1/8 of whatever the population is. So the amount that the population increases will not stay the same every year. So this would be an exponential function in number 11. Okay? And we're going to explain this by 1/8 will not be the same amount each year. Okay? So that means, like, let's say there's 16 wolves. If it increases by 1/8, that means it's going up by 2 wolves. So now we're at 18 wolves. But if we have 18 wolves and it increases by 1/8, that would be a little more than 2 wolves. So the amount that it's increasing will not be the same amount. So each week, number 12, Jimmy practices his guitar for 1 hour longer than he did the week before. Okay, so we know that he's practicing his guitar, and it's for 1 hour longer than he did the week before. Okay, so one thing that you might want to do if you're not sure if something is linear or if it's exponential, you could make a T-chart. You can make a table, like what we were doing up in numbers 1 and 2 and 5 and 6. Okay, so what we could do is we can make a table where we have week, and then we could have hours practiced. Okay, so hours practiced. And we can make a chart and we can compare. So let's say in week 1, he practices for 1 hour. Okay, so he's going to practice for 1 hour. Now in week 2, it says he practices for 1 hour longer. So that means in week 2, he's going to practice for 2 hours. That's 1 hour longer than week 1. In week 3, he's going to go 1 hour longer than this, the previous week, so it's 3. So you could see that the amount that we're increasing is always going up by 1. It's staying constant, so this would be considered a linear function. Okay, so the amount practiced is increasing at a constant rate. Okay, and in this case, the constant rate is 1. So the linear amount practice is increasing by a constant rate. Okay, all right, the next problems, number 14 through 19. We're going to, once again, we're determining if the function's going to be a linear function or an exponential function, or if it's going to be neither linear or exponential. Okay, so in number 14, you could see we have x as the exponent. That would make number 14 exponential. In number 15, you could see we have an x right here, but we have an exponent. Okay, but since the exponent is a number, that doesn't make it exponential. Number 15 is going to be neither exponential. When we say neither, we're saying it's neither an exponential function or a linear function. In number 16, there are no exponents at all, so number 16 would be linear. Number 17, just like number 16, there are no exponents at all, so number 17 is going to be linear. In number 18, there is an exponent, but it's not the x, it's a number, so number 18 is neither exponential or linear. And number 19, because number 19 is the same as number 17, and so that's going to be linear because there's no exponents, just like number 17. Okay, so we skipped number 20 on the assignment, We skipped number 21 on the assignment, and now we're moving on to number 22. So in number 22, we have Ronald wants to invest his summer savings. He has $300 to invest and 2 investments to choose from. For any month's T, the balance of investment A is given by the function f of t is equal to 11 times t plus 300, and the balance of investment B is given by the function g of t is equal to 300 times 1.036 to the t power. He built this table to compare the balances over a period of 8 months.